So good day everyone, we are the group MMM. I am Maisel Madasig, Mara Flor Maymad, and Marichel Masangay. We would like to answer the question sheet 3 number 1.
We have 7 arguments. 1. P implies Q, not Q, therefore not P. 2. P implies Q, Q, therefore P. 3. P or Q, not P, therefore Q. 4. P and Q, P or Q, therefore P and R. 5. P implies Q, Q implies R, therefore P implies R. 6. P implies Q, Q implies R, therefore Q or R. 7. P or Q, P implies R, Q implies R, therefore R. In the truth table, 1. P implies Q, not Q, therefore not P. Since we have two components, two rules are composed in 4 rules as we follow the rules. This result comes from 2 raised to 2 so that it becomes 4. We have truth values of P that has value of true, true, false, false, and Q values true, false, true, false. By adding that, we can get the value of P implies Q, and the truth values are true, false, true, true. The rule of implies is it becomes false if their hypothesis is true, but the result is false. The not Q is the negation of Q, so we have false, true, false, true. And we have P implies Q, therefore Q. We have false, 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 false. And it is the conclusion. And the test of value if it is valid or invalid. We can determine by testing its validity the premises if the premises which is the P implies Q, the premises B.
Okay, so let's proceed to the next argument. So this argument 2, we can follow the process from the argument 1. So P implies Q, Q therefore P. So the P values are true, true, false, false. The Q values true, false, true, false. P implies Q values true, false, true, true. Q values true, false, true, false. And P implies Q or Q values true, false, true, false. Next, P values are true, true, false, false. Next, P implies Q or Q implies P values true, true, false, and true. Therefore, the argument 2 is invalid.
Another argument is argument 3, which is the valid argument. How did this argument become valid? So to prove that this argument is valid, we will make a truth table that provides a value. We have now the values of P or Q. P values are true, true, false, false. The Q values are true, false, true, false. The first premise P or Q are true, 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 false. Next, we get the not P values, which is false, false, true, true. The Q values are true, false, true, false. So we can determine if it is valid or invalid arguments by checking it, if tautology or not. We need to have the first premise and second premise, the P or Q, and not P. The values are false, false, true, true. We will use the operator AND by implicating it to the conclusion. Then we get the result all true. which means that the argument is valid.
So the next argument is argument 4. So this argument 4, we have three components or variables which are P, Q, R. In this matter, we can have 8 rows and 2 raised to 3 is equals to 8. We have two premises that P and Q, Q or R is P in R. To get these premises, we need to have truth value of P, Q, R. The P values are true, 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 false, 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 false. And Q values are true, true, false, false, true, true, false, false. Next, R values are true, false, true, false, true, false, true, false. P or Q values true, true, false, 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 false. Q, not R, values true, 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 false, true, 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 false. P or Q, not Q or R, values true, true, false, 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 false. P or R, values true, false, 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 false. The last conclusions, true, false, true, 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 true. So therefore, the argument 4 is valid.